Good evening, everyone. Fluid mechanics. Last time we solved a problem in gate forces by momentum equation. This time we want to solve it with a far simpler approach, which is a specific force method in hydraulics. So I will provide you with the link to the previous video if you don't watch that video. We have a gate and upstream flow comes like a 3 meter cube per seconds at the upstream by h1 6 meters flow comes to the gate, then it just moves to the downstream side by the depth of 2 meters. We want to know what is the force applied to this gate if the width of the gate, if the width of this gate is 10 meters. Last time we solved this equation based off solution 1 in momentum equation, which is in fluid mechanics sigma forces, summation of forces is rho q delta velocities. And in this time, solution 2, we want to solve it by a specific force method in hydraulic. Let's see how we can approach this problem. So in second solution, which is a specific force method, the formula for that is force applied to the gate over the gamma of water is equal to q squared gy1 at the first cross section, or h1, plus a half of y1 squared minus the same terms for the downstream side. Let's see how that comes. If you go to the reference book of FE and PE exams and any other hydraulic or a fluid mechanics reference, you can see the momentum and depth relation in terms of a alternate or sequent depths. This is M, capital M momentum equation, and Y is depth, and YC is the critical depths, which Froude number here is equal to 1, and this is the minimum specific force or momentum of the fluid. So in this equation, y stands for vertical distance for liquid surface to centroid of area in terms of feet of water, and q is discharge, a is area, m is momentum or a specific force, another term for that. And if you just move to a simple case like a rectangular channel, which is the most of the case like for our problem, you can easily see this is y, height of water, y, and let's see half of that goes by centroid. We call that a half of y. Mhm. And if you made it simpler, you can get it q squared over gy plus half of y squared. So if we use this term for both sides of the equation, it should be 2y here. Or it the only difference here is just we just consider the total height is equal to y, and half of that is half of y, so you can use this term like be consistent with our formula in this problem. So, but it's just a derivation of this equation. Mhm. Then if your b is equal to 1 for unit widths, then you can jot down the equation for F over gamma, force over gamma, is equal to specific energy or momentum equation for the first cross section minus the momentum or specific force for the second part. So second cross section. So in our case, if we simply jot down F, gamma is 10 to the force F we are looking for, Q is, this is Q, we already talked about it, 3 squared over g is 10 times y1, which is 6, plus half of y1, y is 6, so 36 minus, move to the second part, q remains the same, 3 squared 9 times 10 to height of water in the second cross section, plus half of 4. And if you do the math, it just gives you F is equal to 1570 kilonewton, which is exactly the same numeric value, but it's a far more uh, quicker approach in comparison to previous solution. Thank you. We'll solve more problems.